Good afternoon all. In continuation of last class, today we are going to discuss about the BCNF, that is Boyce-Codd Normal Form. Here after third normal form, we have BCNF, that is a Boyce-Codd Normal Form. Here already I told you, here when we are going to check the given relation is in a Boyce-Codd Normal Form, BCNF, that relation must be in the 3NF as well as 2NF and 1NF. That relation must be third normal form, second normal form and first normal form. So that only we can apply the Boyce-Codd normal form. Here that is what exactly. Here what Boyce-Codd normal form it is going to tell and how to understand and how to solve the problem and how to avoid the redundancy with help of Boyce-Codd normal form. Today we are going to discuss. So before entering into the Boyce-Codd normal form, so please let me again we can check our third normal form definition, second normal form definition, first normal form definition. Anyone please tell me what is first normal form? Quickly. What is the first normal form? Hello? Just I am remembering the things. What is the first normal form? Very important. That's why I am taking 1 hour for one normal form. And yeah, Yogita, repeat.
So each attribute is having atomic values.
Yeah, in a relation, every attribute must be the atomic. In single value attribute, it will be accepted. If it is not a single value attribute, you need to convert it so that that relation is converted into the first normal form. 100% right. Now, what is the second normal form? What is the second normal form? Hello. Don't waste my time. What is the second normal form? Hello. I am asking a very simple question.
Functional dependency.
Can you repeat Anusha once?
There must be full functional dependency to apply the second normal form.
Yeah. Second normal form is accepts only full functional dependency. It avoids the partial functional dependency. If after verification of all functional dependency, you need to check only full functional dependency. If there is any partial functional dependency, you must be avoid, you must be decompose the relation based on the partial functional dependency and convert into the full functional dependencies only in the relation. That is a second normal form. When we are checking a relation, for the second normal form, you need to check that relation must be in the first normal form. Later, we apply this second normal form for the verification of only full functional dependencies. So this is second normal form. Okay. Now tell me third normal form. What is the third normal form? Quickly.
There must be transitive dependency.
There must be a transitive dependency, or it is avoiding the transitive dependency.
It avoids the transitive dependency.
The information very important. Otherwise, you people will get confused. Here, third normal form. When we are going to check the given relation is in a third normal form, here the relation must be in the second normal form, must be in the first normal form. Then you apply to a third normal form. Here to identify functional dependencies, if there is any functional dependencies having any transitive dependency with along with that, for example, A determines to B determines to C. Then that B is a candidate key. We can tell because A determines to B. Because B is a non-prime attribute because A is a prime attribute. So now again B is determines to C, so that there is a chance of B is a candidate key. When you are having any trivial dependency, A determines to B determines to C, means that B is a candidate key because B is not a primary key. Why? Because you are defining A determines to B. Here, if you are defining A determines to B, means B is not a key attribute, primary key attribute, prime key attribute, because it is depending on A. So that it is maybe a candidate key. So that's why B determines to C. So that we can write A determines to C. Here, this is the problem. The third normal form is going to avoid trivial dependency, and you are going to break the candidate key problem also. How we are breaking? A determines to B. AB you can write into one relation, BC you can write into another relation. Then what happened? Here A determines to B depending on A, there is no candidate key, and B determines to C is depending on B, there is no candidate key. Here indirectly we are removing the candidate key. Means trivial dependency you are removing. So this is what exactly the third normal form. All of you clear?
Yes, sir.
Yeah. Now coming to the BCNF, here most of the people will confuse with third normal form to BCNF because BCNF is a Boyce-Codd. Already I told you this normalization techniques is proposed by Codd, Boyce-Codd. Here, Codd is the author, is the scientist. He only suggested these normal forms. So that's why, because of his name, one normal form they kept as a BCNF, Boyce-Codd normal form. Here, Boyce-Codd, Codd rules. Some people will call these rules, normal forms are called as Codd rules. Are you clear? Are you clear? Hello?
Yes, sir.
Yeah. Yeah, that's why this is a Codd rules. Here, Boyce-Codd. Okay, his name is Boyce-Codd. Based on his name, they are given a one normal form. Here, that is a BCNF. A BCNF is a sometimes some people will tell it is a advanced version of third normal form. Here, it is going third normal form is adding one more feature into the third normal form. Here that is a BCNF. That's why most of the people will confuse with BCNF and third normal form. That's why today we are going to understand BCNF along with I will compare with BCNF with the third normal form because so many areas, maybe your examination placements everywhere, they will ask the comparison, and even students or maybe the faculty or maybe anyone, they are going to confuse BCNF to third normal form. It is closed relative functional dependencies. Are you clear?
Yes, sir.
So please, I am telling very important normal forms. When you go to the placement, that time you can face a lot of problems. Please follow. If you are having doubt, ask me immediately. Right. Now coming to the Boyce-Codd normal form, as I told you just now, a normalized relation schema R is in a Boyce-Codd normal form if for every non-trivial functional dependency. Just now only I told you is a third normal. So there also we call about non-trivial. It is avoiding the non-trivial dependency. Same third normal form also it is going to avoid the non-trivial, means trivial dependency it is going to avoid. Yes or no? Yes or no? Hello? 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 In third normal form also, we are going to avoid the transitive dependency. Yes or no? Trivial
Yes,
dependency, transitive dependency, both are synonym names. Yes or no?
sir.
Yes, sir.
But in this BCNF also, it is going to avoid the trivial dependency, means it is having a non-trivial. Non-trivial means avoiding of trivial mechanism. Here that is the F plus of the form, closure set of the form, X determines to A, where X subset are equals S and A belongs to S, X be a super key of R. Now X is a super key. Now in third normal form, what is that? X is a what? What is the X in the third normal form? Hello? In third normal form, X is what? X is a candidate key. Understand? Hello?
Yes, sir.
Hello? So this is the difference. Here in a third normal form, X is a candidate key. In BCNF, X is a super key. What is the difference? Candidate key to super key?
Candidate key is the
Hi Kiran, please
subset of
unmute your mic. Your disturbance is coming. Mr. Sai Kiran, 538. Okay, repeat. Can you repeat? Someone is telling Anusha or Yogita? Someone. Do you understood?
Candidate key is the subset of super key.
Yeah, candidate key is a subset of super key because here all attributes in a relation contain super key. Only part of the attributes maybe you can tell as a candidate key. Here in a third normal form, here we are going to concentrate on candidate key. In Boyce-Codd normal form, we are going to concentrate on super key. So this is the difference from third normal form to Boyce-Codd normal form. People will confuse a lot, but very easy. Are you clear? Are you clear?
Yes, sir.
Sometimes when we are going to convert the given relation into third normal form, sometimes automatically that relation is belongs to BCNF also. Understand? So don't confuse, sir. I applied only third normal form. Automatically it is available in the BCNF. It is possible because maybe there is no candidate key. Directly there is a super key. Then automatically it will be comes to the BCNF. Understand?
Yes, sir.
Means all the relations which are there in the BCNF sometimes may or may not in the relations which are in the third normal form or may not in the BCNF. Sometimes it is directly comes to the BCNF, sometimes it never. Because there is a chance of this trivial mechanism we are checking. In the trivial mechanism, instead of candidate key, directly we got super key, and directly it will be converted to the BCNF. This is the difference. Clear? Clear?
Yes, sir.
Right. Now, BCNF removes the remaining anomalies that results from the functional dependency, same like that. Here, BCNF, the attributes on the left-hand side of functional dependency must be a candidate. Left side must be a candidate. According to the Codd's rule, already I told you, because of this is a Codd rules, all normal forms are based on Codd rules only. That's why this is a Boyce-Codd normal form. A relation schema R is in a BCNF if it satisfies 3NF, but when a relation has more than one candidate key, anomalies may result even though that relation is a third normal form. Here, this is what exactly. Here, I will show you some more definitions, Boyce-Codd normal form. Please follow the notes and practice in your databases so that you can get more idea. Right. Again, a bookish way I can tell you, BCNF is the advanced version of third normal form. Already I told you why it is advanced. In a third normal form, we are concentrating only candidate key. In a BCNF, we are concentrating on super key. That's why it is the advanced version of 3NF. Yes or no? Yes or no?
Yes, sir.
And it is more stricter than third normal form. Why it is more strict? Then third normal form is candidate key, some of the attributes. But BCNF is all attributes because super key. So that's why it is more stricter than third normal form. And a table in a BCNF, if every functional dependency X determines to Y, this X must be a super key. This is very important information. X must be the super key. In a star normal form, this X is a candidate key. We told that time X is a candidate key. But here, X must be the super key. Yes. Are you clear? This X must be the super key. Are you clear? The difference between third normal form to BCNF. All of you clear? Hello?
Yes, sir.
Yeah. Now, for BCNF, the table should be in third normal form, and for every functional dependency, left LHS means left hand side is super. X determines to Y. If you write, what is the LHS here? If you write a functional dependency like this, X determines to Y, in a BCNF, LHS must be a super key. What is the LHS here? Any one of you tell me? In this relation, what is the LHS? X determines to Y. Hello?
X.
Left hand side. LHS is nothing but a left hand side. Here X is a super key. When if you are going to work out with BCNF, the functional dependency is X determines to Y. The LHS of must be a super key. In this case, X determines to Y. If you write that X must be a super key. Clear? Clear? Clear?
Yes, sir.
If it is in a third normal form, if you write X determines to Y, the LHS must be what? The LHS must be what? Hello? Hello? If it is a third normal form, the LHS must be what?
Candidate key.
Candidate key. Yes, good. Right. Now coming to the example. Now one table, that is the employee table. Employee ID, employee country, employee department, department type, employee department number. Here now employee ID. Here if you take employee ID, here employee ID, remaining all the details are going to depending on employee ID. Yes or no? Student all ticket number, remaining all the details are going depending on student all ticket number or not? Yes or no?
Yes, sir.
So that employee ID is a primary key. Correct? Because all remaining details are depending on employee ID. Yes or no?
Yes, sir.
And department type and department number is depending on employee department. Yes or no? Yes or no? Hello? Hello? In the same relation, all the attributes are depending on employee ID. Here, definitely employee ID is the primary key. Yes or no? Hello?
Yes, sir.
Now, in this, again, there is a chance that employee department number, employee department type also depending on employee department number. Sorry, employee department number. Yeah. These two are depending on employee department number. Now, even employee department number also depending on employee ID. Here, this is what exactly. Now, what happened? You need to decompose because here transitive dependency is there again. Here, employee ID determines to employee department number is determines to employee department number, employee department. But you must make it. Left side must be the super key. So that's why here we can define employee ID and employee where are the employee ID and employee country, as well as, because here it is completely employee country depending on completely employee ID. If you observe, India 264, 264, UK 364. That's why it is completely depending on. But employee department is not depending. The department type and employee department member. Because there is no any dependency. Is there any dependency? Check this. No dependency. Yes or no? Only the dependency is department type is depending on employee ID. Correct? Because 264, wherever the 264 is there, the D394, D394 is there. That's why it is depending. But employee department number and employee department is not completely depending on employee ID. Yes or no? Yes or no?
Yes, sir.
So that here what should we do? Here we are going to implement decompose your relation, that is employee ID and employee country into one relation. Along with that, we need to take department type also under the consideration. Means we need to design EMP ID, employee country, and employee department is one relation. Are you following? Another relation is employee department and employee ID is another relation. Are you clear? Are you clear? Employee ID, the first relation is employee ID, employee country, and department type is first relation. The second relation is, again, because functional dependency is required, department type, employee department is another relation. Are you clear? All of you clear?
Yes,
Hello?
sir.
Yeah. So this is what exactly the decomposition. Why like this? For employee country table, employee ID, employee country. There are only two. The employee department table. Again, we need to define employee department type, employee department number, and employee department mapping. You need to map these two tables again because we cannot find the data. That's why employee ID and employee department. Here, because in a BCNF, don't expect after decomposition that must be a two tables. Sometimes this BCNF, the solution is not solvable based on the given functional dependency. That's why here we have taken employee country table, employee ID, employee country, and employee department type, employee department number. Okay, but you need to map these two, right? So that's why your employee ID and employee department we need to map. So employee ID and employee department, we need to map these two tables. So you need to prepare one more table so that only we can solve the problem. Here, if you observe here, employee ID, employee country. Now it is a primary key. Now left hand side must be a primary key. Automatically it is a super key. Now employee department. Here all these values are depending on employee department. That's why it is again a primary key, nothing but a super key, and employee ID and employee department. So it is also a primary key is nothing but a super key. Because all the things must be under consideration. So that here left hand side must be super key. So don't expect always the table is divided into two tables only, sometimes three, sometimes two only. Here in this example, we need to map these two things. So that we need again employee department mapping table also required, because this is a department table, this is an employee table. The employee works in the department. Here that is the mapping. The relation set is employee ID and employee department. Here this is what exactly we can do it. Clear? All of you clear? Hello? Is this clear? Still any doubt? Hello. Is this clear? Still any doubt? Hello. I'm not getting any response from your side. Is this clear?
Yes, sir.
Yeah.
Yes, sir.
Don't confuse a simple the mechanism. One more example also I will show you. Here employee table, employee ID, project ID, department. Here now, if you observe the candidate keys, employee ID, project ID determines department. Because here there is no dependency. Compulsory we need to make it both employee ID and project ID only it will be define the department. So directly employee ID cannot be defined the department because employee ID is one and it is account. Same employee ID is one, but the department is sales. Okay, that's why it is there is no complete only one attribute to define the particular another attribute. So that we need to go with the two attributes so that we can define the department. Means employee ID is one, project ID is 23, then accounts. Employee ID is one, project ID is 67, sales. So like that, we need to take two attributes, then it is will be defined to another attribute. Understand this, first of all of you?
Yes, sir. Yes, sir.
Now it is two attributes. Means it is a subset of super key. That is what this is the candidate key. Employee ID plus project ID is the candidate key. So that only we can solve this functional dependency. Now, department which is not a super key, exactly. So this department is not a super key because it is depending on candidate key attributes. So it must be depending on the project ID. Exactly, it must be depending on the project ID along with the employee ID. Anyway, employee ID is the primary key, if you feel. But here it is not a primary key because different same values we are having more than one time. So that it is not a primary key. But project ID and employee ID. So that this is a candidate key. Understand? As per this table I am telling. Are you clear? As per the data of this table, just this is the information. Are you clear? For BCNF, you need to verify the values so that only we can get some conclusion. Are you clear?
Yes, sir.
Now, department is determines to project ID. Once you check, department is determines to project ID. Means project ID is depending on department. Once you check, no, it is also not possible. So this is also not possible. It is not working. So that we need one more attribute to add. So that we need one more attribute to add for this particular table so that only we can avoid this type of candidate keys for the dependency. So for that they are added one extra attribute, that is a project. So then only we can decompose the relation. Here how we are going to decompose the relation? Here employee ID and project ID we have taken as one table, and project ID department we are added extra attribute here. So this project, this particular sorry, what I can tell, project is the extra attribute here. Here project is not there in this original table, means given table, but without project we cannot do that because we cannot solve the problem. So that we need to add project extra attribute and we need to fill the data accordingly this particular department ID, so that the project ID is going to map. Because wherever the things are required, we need to add. Here, just if you check here, 63 is extract project. Again, you take where is the 63? There is no here 23 is the 23 is the extract. Again here 23 is the extract. Again here 23 is the extract. Means Here is that particular project is depending on the project ID. That's why your functional dependency, it is not there, so that we need to add extra attribute and define the functional dependency, so that only we can get the BCNF. Understand? Hello? The different cases I am explaining one by one. Here we are divided. At the time of division, we need one more table, so that we are added. Here also, if we need one more attribute is required for dependency. If there is no dependency, if you observe here, there is no dependency. Yes or no? Base table, is there any dependency? The employee ID is not related to project ID and department also. Because here employee ID, department, accounts, sales, the same employee ID, not possible. Project ID, not possible. That's why here we need a one functional dependency for that, so that we can add one more at the time of decomposition of your relation. We need to add one more attribute. That's a project I have taken here. Then based on this, here this project is depending on project ID, so that we can do the things. Are you clear? Otherwise, there is a problem for the lossless join and dependency preservation. So that we need to solve this. All of you clear? Hello? All of you clear? Hello? I'm not getting any response. Is this example is clear, everyone?
Yes, sir.
Yeah. Now coming to one more example. I will show you some more examples, don't worry. The ground, now this is very famous example. Now the ground, begin time, end time, and package. Here now, if we want to use a ground, here they are having some charges starting this time and ending this time. And this is the package. Some packages are there like that. Now, if you observe this, when we are going to observe this given relation is in what I can tell, all are in a third normal form. It is not in a BCNF because there is a reason function different. Package determines to ground. Your package determines to ground. G01 is gold, G01 is gold, and G01 is bronze. But there is no dependency, right? So this is the problem. Understand? Hello? There is no trivial dependency. There is no partial functional dependency. There is no multi-valid attribute. But here there is a problem with BCNF because there is no dependency. That particular x determines to y means x determines to y means x must be a super key. But here this is not a super key, or maybe it is not a key, because here if you observe G01 gold, G01 gold, but G01 bronze. That's why it is not depending. Same like this also. Here also same problem. Here one accounts, one sales. So that is what there is no dependency reservation. So that this particular relation is not in a BCNF. That must be a super key or maybe the key left side. Understand? Hello? Are you clear? Hello? Are you following? Is this clear? My voice is clear.
Yes, sir.
Is this clear? What I told you, is this clear? I am not getting any response.
Yes,
Hello?
sir.
Yeah, yes, okay. Please respond quickly, time is running. I need to finish this. Now, this is the problem. So that it has the determination attribute for the ground depends in a neither candidate key nor superset of the candidate key. There is no dependency. When you observe a package with ground, gold, when you check the gold G01, G01, and silver G01 and bronze also G01. Here, but when you observe here, this is not exactly that's why reverse manner. The package is this particular package is not depending on ground. You need to take package determines to ground. So this is also somewhat different mechanism. G01 and goal. So in that way, you can take ground, begin time and end time. Understand? This we cannot tell. This is a compulsory G01. Maybe the begin time and end time we cannot change anything. But if you want to use this mechanism as a BCNF, instead of taking package determines to ground, then you need to decompose that, and we need to use different table so that we can get the only here 1, 2, 3, 4, 5. 5 records are required, but when you do this decomposition with help of BCNF, there is no primary key. But now it is a super key now when you are going to define, because we are not defining all. But here we can define so that we can get only 3 records. Yeah, with this we cannot change any redundancy. Already I told you we can avoid some redundancy only with the help of normal forms. So that we are avoided here. So this is what this example for the BCNF. Understand? Very simple. Have you understood this? Here in BCNF, different problems, we need to think different way. You don't think only like only full functionality will be support, multiple, not like that. Here we need to check here what the things are there. The left side must be the key attribute or not there. If it is not there, then you need to decompose. You make it as a left side must be a key attribute. This is the idea. Understand?
Yes, sir.
Yeah. Now, this is very famous example, third normal versus BCNF. If you understand this, then automatically you can understand BCNF. Actually, this example is there in Wikipedia. Here, Wikipedia, even you can search in the Wikipedia, you will get this example for BCNF, because people will confuse with 3NF to BCNF, so that we can solve the particular given relation in a 3NF as well as BCNF so that we can understand. Now come to the point. Here same code I have taken the start time and end time and rate type. Okay, these are the rated categories. Now the table super keys are here S1. Here S1 first super key. If you want to think current, here what is the current status? 1. Okay, current start time, current end time. Like that we can have all combinations. All the combinations of super keys. When you observe this, all combination, here there is a chance of trivial super key. Why? Because here quote is there everywhere. So that's why here we can get there is a trivial dependence, so that we need to avoid that. So with the help of third normal form, we need to avoid the trivial dependency, because this quote is the candidate key in this case. If you apply third normal form, but if you apply third normal form, the technique is you cannot guarantee that rate type equal to code. Here, if you use only third normal form here, rate type determines to code. Here, is there any chance to rate type determines to code? Here, this rate type always determines to code. Remember, means saver 1 is there, but here standard is there, here 1 is there. Here, can you solve this for third normal form? Because third normal form always you can ask complete functional dependency. Is this going to solve using third normal form? Hello? Hello? Are you following?
Yes, sir.
Yeah. We cannot solve, because rate is saver and 1. Here standard again 1 means it is not possible. Means we cannot write directly x determines to y here. So this is the problem of third normal form. So that there is a solution in the BCNF. Just now I told you before example also. Here package not determines to ground here, because gold G01, okay. Silver G02, okay. Bronze again G01 because of this. So that's why we cannot solve this here with third normal form. But BCNF we can solve. How? We can add, even if you want to decompose directly like this also you can decompose. Otherwise, we can add one extra attribute. Even we can add extra attribute, that is a flag here. One extra attribute I am taking in a BCNF, that is a flag. Here flag is here. I can take a small like that. One flag if I take here based on the table, then we can do the member flag after decomposing. How to decompose? Generally, how to decompose here? Quote and rate type is one table. Quote and rate type is one table, and quote start time and end time is another table. But along with that, if I take a member flag in both the areas, here this is the member flag of extra attribute. This is a member flag of extra attribute. Now after decomposition of this relation, now there is a chance of dependency, functional dependency, and lossless join. Are you clear? Are you clear? Hello? Hello?
Yes, sir.
Yeah, here this is the way we can use BCNF. Here I given different flavors of BCNF examples. Based on these examples, we can understand sometimes some categories of examples they are going to ask in your interviews and your placements, even though in your examination also. So that I given very clear different categories of example. Please go through that and work out the things. Now, coming to the differences. Here, what are the basic differences of BCNF and third normal form? We will check. Before going to the differences, all of you clear about BCNF? All of you clear about the BCNF?
Yes, sir.
Yeah. Now, the differences. Here, if you understand this difference also, we can have more knowledge, and sometimes people will ask in your examinations and interviews also. The third normal form. The first point is, in third normal form, there should be no transitive dependency, that is, no non-prime attribute should be transitively dependent on the candidate key. So this is what exactly the third normal form definition. It never accepts the transitive dependency, and there is no non-prime attribute should be transitively dependent on the candidate key. Means if you write x determines to y, if you feel y is a prime attribute, y is a prime attribute, x never be the candidate key. So this is the meaning. Means the third normal form never accept this transitive dependence 100%. But if you are writing like this, x determines to y, y determines to z, this never accept. And if you feel this z or maybe the y as a as a prime attribute, maybe the primary key, maybe this y is a primary key. If you feel if that never depending on the candidate key, means x not be the candidate. If x is a candidate key, now prime attribute is depending on x, because we are writing y determines to z also. If you are writing x determines to y, y determines to z, there is a chance of y is a prime attribute. If y is a prime attribute, then this x determines to y we are writing, then y is a prime attribute, it is depending on the candidate key. If it is x is a candidate key, y is depending on x. So now your prime attribute depending on candidate key. That problem we are going to solve with the help of third normal form. How to solve? XY is one table, YZ is another table. What happened? This is separate table, this is separate table. Your Y is depending on X, Z is depending on Y. If there is no chance of transitive dependency, as well as there is no chance of prime attribute is depending on the candidate key. Understand? Understand?
Yes, sir.
Now, same thing in a BCNF, the definition is in BCNF for any relation A determines to B. If you are writing A determines to B, A should be a super key of a relation. Yes, we can do same mechanism. X determines to Y determines to Z. Yes, it is not accepting transitive dependency, BCNF, everything is same. But this X, here we are telling X not be a candidate key. Simple. In a BCNF, we are telling X must be a primary key. So this is the difference. Sorry, super key. X must be a super key. Understand? Here in third normal form, we are telling this X determines to Y determines to Z. X must be not be a candidate key. In BCNF, same X we are telling it must be a super key. Understand? The mechanism is understand? Hello? The definitions, all of you clear? Third normal form to BCNF? Time is running quickly. Hello?
Yes.
Yeah. So this difference, if you observe, the implementation is very easy. Are you clear? Are you clear? All of you
Yes,
clear?
sir.
Yeah. Very good. Now coming to second difference, it is less stronger than BCF. 100% it is a less stronger than BCNF. Third normal comparatively, BCNF is more stronger than 3NF 100% because here we are checking X directly must be super. Now, in third normal form, the functional dependencies are already in first normal form and second normal form. In BCNF, the relation must be in a first normal form, second normal form, third normal form. Correct? Yes or no? Yes or no? Hello? What happened? No response. People are sleeping. If the relation is in a third normal form, that must be a first normal form, second normal form. If the relation is in a BCNF, that must be a first, second, and third normal form. Yes or no? Hello?
Yes, sir.
Yeah. Now coming to the redundancy is high. Yes, exactly. In the third normal form, comparatively BCNF, the redundancy is high. Here, high. In a BCNF, compared to third normal form, the redundancy is low, 100%, because it is going to avoid more redundancy compared to third normal form. In third normal form, there is preservation of all functional dependencies. Exactly. If there is a preservation is there in functional dependence in third normal form because we only going to check X not be a candidate key. But in BCNF, there may be not be preservation. Here it is going to avoid all the functional dependencies. Okay, it is going to avoid all the functional dependencies so that BCNF will get more less redundancy in the relations. Now it is comparatively easier to achieve. Exactly, this third normal form easily we can because wherever X determines to Y determines to Z, we can apply, we can decompose. This is one, this is another relation. Very easy. But when it comes to the BCNF, here we need to check again, along with this decomposition, we need to check again, X must be a primary key. This Y must be a primary key. If any attribute is required to add, you add for this implementation. And after decomposition, the that dependency preservation and lossless join we need to check. That's why it is a more difficult to achieve. Understand? Understand? No?
Yes, sir.
Yeah, based on that, in a third normal form, lossless decomposition can be achieved easily. But in a BCNF, lossless decomposition is hard. Already I told you just now. Here, if we want to achieve this lossless decomposition, we need to add sometimes extra attributes after decomposition in a BCNF so that we can achieve the lossless joint decomposition. So that is what just now we discussed here. Okay, we have to add member flag so that only we can get the lossless joint decomposition. Clear? All of you clear about BCNF and difference of third normal form and BCNF?
Yes, sir.
Yeah. Now only two topics are left for third normal forms. So before fourth normal form, we need to discuss about multi-valid functional dependency because Fourth normal form only depending on multi-valued functional dependency we will discuss, and fifth normal form almost only one session is enough or two sessions are required for completing of this particular fourth and fifth normal form along with multi-valued functional dependency. All of you clear up to BCNF? Four normal forms are clear?
Yes, sir.
Now please try to